Here's a quick lesson on how to combine like terms. The goal of this video is to identify like and unlike terms, and also to combine like terms to simplify an expression. When two terms have variable factors or variable parts that are exactly the same, the terms are called like or similar terms. Consider the following terms. 7x and x are like terms because they have the same variable part. 2y squared and negative 4y squared are like terms, and so are 5 and 8. Unlike terms would be something like 7x and 3x squared because the variable parts are not exactly the same. Though these both have factors of x, this has one factor of x and this has two factors of x. Therefore, they're not like terms. 2xy and x are unlike terms, and so on. The distributive law enables us to combine or collect like terms. Remember, the distributive law tells us that A times the quantity B plus or minus C is equal to AB plus or minus AC. However, for combining like terms, it's often helpful to write this in the opposite order so that we have AB plus or minus AC is equal to the quantity B plus or minus C times A. Notice both terms have a factor of A, which we can factor out. So looking at this in the formal way, if we want to add or combine 5x cubed plus 2x cubed, notice both terms have three factors of x, so we can factor that out, which leaves us with 5 plus 2, which equals 7x cubed. Now formally, this is what allows us to combine or collect like terms, but in practice it is often more convenient to identify the like terms and then add or subtract the coefficients and leave the variable part unchanged. So notice how if we identify these as like terms, we can just add 5 and 2 to get 7x cubed. So if we want to combine like terms here, step 1 is to identify the like terms. 7x squared and minus 3x squared have the same variable part. You could almost think of it as the same code. And then we have a 12x and then a minus 9x. Those are also like terms. So you could almost think of this as the x's are apples and the x squareds are oranges, whatever works to identify the like terms. So 7x squared minus 3x squared would be 4 because 7 minus 3 is 4, with the variable part staying the same. And the x term would be 12x minus 9x. Well, 12 minus 9 would give us 3, so plus 3x. Next problem, let's identify the like terms. We have a couple y cubed terms. We also have a couple z terms. So we know when we combine our like terms, we will have a y cubed term, and the coefficient will be 9 minus 11, which would give us negative 2. We know we'll have a z term. The coefficient of the z term will be 2 minus 2, which would give us 0. And then notice we have this minus 12 left over. We also have to include that. Now notice this term has a 0 coefficient, so that would be 0. So we can rewrite this as negative 2y cubed minus 12. We don't want to leave 0z in our simplified expression. Okay, let's take a look at one more. We need to be careful on this one. The variable part here is a cubed b squared. So this is not a like term, this one is. Next, we have an a squared b cubed term and another one here. Now they do want us to put the highest degree terms first, but both of these have degree 5, so it doesn't matter which one we choose. Let's go ahead and list the a cubed b squared term first. The coefficient will be, in red, negative 3 plus 7. That would give us 4 a cubed b squared. The next term will be the a squared b cubed term, and the coefficient of that term will be negative 5 plus 1. Negative 5 plus 1 will be negative 4, so we write minus 4 a squared b cubed, and we have a constant term that we also have to include. So now we've combined all of our like terms. Hopefully you found this video helpful. Thank you and have a good day.